Hey guys, two things when it comes to solving quadratics that I wanted to cover. Two sort of formulas that you can use. You can use them either way you want. You can use them this way if you're given some term squared minus some other term squared. You can divvy up those terms, you can factor those terms like that, or you can go the other way. The same, actually, let me use a different color. The same can be done up top here. Before I really explain this or get into this or prove this, if you will, let me give you an example of each. Let's start with the top one. We'll go right to left, if you will. So for my a squared, I'll pick x. This is actually one of the homework problems for those of you guys who check them out. I'll leave my 2. My a is my x, and before I put in the second part of this, let me give you guys the b. The b is going to be 14 squared. So that'll be 14. So what this problem is going to actually look like, again, we're doing one of these examples. What this problem is going to actually look like is x squared plus 28x plus 196. Some of you guys are like, oh, that's this problem on the homework. I'm not going to tell you which one. But it is one of the problems on the homework. So take notes or pay attention if you want to see how to do it. A lot of the problems on the homework actually model this process. But anyway, they want to know, when is this equal to 0? Now, we've done graphing before. Conceptually, we understand this is a positively sloped thing. Positively sloped equation, and we want to find out, where does this parabola either intersect through 0 like that, intersect through 0, I don't know, like that, where those are the zeros for y equals 0, or maybe like it just touches the line like this. It just touches the line briefly. But visually, that's what we're looking for. We're looking for when y equals 0, what is the x value for this particular function? But let's not do it visually. Let's do it the method that they're telling us to do it. They're wanting us to factor. Now, knowing what we know up here, if this formula is indeed a squared plus 2ab plus b squared, we should be able to immediately factor this into a plus b squared, where a is x and b is 14. Almost wrote a. X plus 14 squared. Now, x plus 14 squared equals 0. Assuming that this is true, I'm going to prove it in a second. But this is my a, this is my b. You can see this squared. X plus 14 squared equals 0. When does this equal 0? Well, I hope that it's somewhat obvious. But when you plug in negative 14 for x, negative 14 plus 14 squared is just 0. Let me give you an example of the other formula that we have here, and then I'll prove them both. Don't worry. I am going to prove them. All right, let's say that we have, for our a, in this case, I'm going to go left to right this time. For our a, we have x, and that'll be squared, minus, let's go with, I like 9 squared. I like it. I don't know why, but I do. Following that, if I have 9 squared there, or you know what, I could also make this x squared minus 81. Another way of thinking about it, just so you know. I would break it down as my x minus my b, and then multiply it by x plus my b. And they should be equivalent when multiplied out. I'm going to show you this one, and then I'm going to show you the actual abstract, and then I'm going to show you the top formula, the one underlined in green for squares, solving for solving using squares when it comes to factoring. So for now, let's solve this one out. It should equal x squared minus 9 squared, or x squared minus 81. That should be the answer. Is it? Let's find out. That'll be x squared. That'll be plus 9x. That'll be minus 9x right there. And then that will be minus 81. 9x minus 9x, those just cancel out. So that is indeed x squared minus 81. Let me show you the abstract. A minus b times a plus b. A squared plus ab minus AB or BA, AB. It doesn't matter. Commutative law doesn't matter how you multiply, whether you multiply like that or like that. 2 times 5 is 10. 5 times 2 is 10. Doesn't matter what order you multiply them in. So plus AB minus AB, and then minus B squared. And we'll have A squared plus and minus, those cancel, minus B squared. Prove it. No, that's a bad square. If you prove something, you can draw a little square at the end there. Let me just prove this top one so that you guys see what I'm talking about. This top one, a plus b squared. Let's set it up. That'll be a squared plus ab plus another ab plus b squared. This time they don't cancel out, they instead combine because there's 2 of them. A squared plus 2ab plus b squared. Cool. This is indeed what we have up there. So there you go. Hope that helps. Hope you guys are having a great weekend. Bye.